Math 2414, Series Video 1, From Sequences to Series. There's a lot of videos in this video series, but I'm going to try to keep them relatively short because I know that since I've been recording videos in Zoom, they tend to go just a little long. So I have a stopwatch going. Keep an eye on how long I have been recording, and I'll try to keep them fairly short. All right. So as I alluded to at the beginning of the last series of videos about sequences, we're building up towards representing functions as infinitely long polynomials. We've still got a ways to go to get there, although you'll see your first example today. But in order to get that, we got to transition from sequences to series. So how do we do that? Well, let's start by supposing that we have a sequence. And remember that when I type these things in Zoom, I use function notation, A1, A2, A3, all the way to however far it wants to go. But if I were writing it, I would write it using subscripts, A1, A2, A3, comma, dot, 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 comma, AN. And honestly, you can have a finite sequence that stops somewhere, although those are uninteresting because they're all predictable. It's the infinite sequences that we're more concerned about, and hence infinite series. So what is a series? In short, the sum of a sequence. If you have a sequence, then you can form a series by simply adding its terms. Now, what if it's an infinitely long sum? Well, we're going to discuss what it means for those sums to converge if they converge at all. You may be familiar with this notation for writing a series. In fact, you should be, because you've had Calculus 1 and you've seen sigma notation when writing Riemann sums in definite integrals. But we could write a series from a sequence by saying, all right, let's say we start, not sure what happened there. Oh, I know what happened. Because we're talking about series and my phone is nearby, it's going to think that I say this word. It happens all the time when I teach calculus too. Now, anyway, we can write an infinite series by using sigma notation, by saying we're going to add from 1 to infinity, or whatever the lower limit is, because the sequence doesn't have to start at 1, and we're going to add the nth terms. So that's shorthand for saying A1 plus A2 plus A3 plus wherever. AN, well, we can't say AN because that's already reserved, so we don't really need to pause. We could just say this goes on forever. And we'll discuss what it means for an infinite series to converge or diverge. Technically speaking, a series doesn't have to be infinite. A series could stop. It doesn't have to go all the way to infinity. So for example, trying to get rid of the infinity. Yeah, this is getting silly. All right, well, let's just put it this way. A series doesn't have to go on infinitely. It can stop at a number. For example, if it stopped at 3, then we would just chop it off here. But finite series are not very interesting in calculus. There are classes where finite series are of more interest, but not in this class. We will be dealing primarily with infinite series. Now, you've actually seen infinite series a lot longer than you may think you have. For example, phone again, talking to it. For example, when you first dealt with fractions back in elementary school and learned that there are decimal equivalents to fractions, you were actually dealing with infinite series and didn't even know it. For example, 1/3, as most of you should know, is 0.3 repeating. But what does that literally mean? Well, it means 0.33333 dot, 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 dot. Well, that means 0.3 plus 0.03 plus 0.003 plus 0.0003 and so on. And we can even write these as fractions by saying 3/10 plus 3/100 plus 3/1000 plus 3/10,000ths, and so on. So when you see a repeating decimal, you're actually looking at a short way of saying an infinite series. Again, an infinite sum of a sequence. That's the main difference between sequence and series. A sequence is an ordered list of values. A series is a sum of a sequence. For something like 5/32, as a decimal, if you were to divide it, it would be 0.15625. But without breaking it down into the sum of 5 separate decimals, we could write this as 1/10 plus 5 100ths plus 6 1,000ths plus 2 10,000ths plus 5 100,000ths. So we could think of it as the sum of a finite sequence and hence a finite series. So we've actually seen these things before. We just never pause to call them series or infinite series in the case of a repeating decimal. All right, so to wrap up this video, which is just hitting the 6-minute mark, a series is simply the sum of a sequence.